Welcome to lesson 5 in statistics here, and in this lesson we're going to talk about probability, just the basics of probability. The probabilities, we're going to get a definition here. The probability of an event, this is a word you're going to see a lot. The probability of an event is the proportion, sometimes understood as a percentage or a fraction or a decimal. It's the proportion of times the event occurs in a limited number of observed situations. Okay, so basically the idea is if something happens, let's say 43 times, and out of 60 possible times for it to occur, we would say that the probability is 43 out of 60, or a fraction, 43 of 60. Okay, that would be the proportion. And if we turn it into a decimal, we would also call it a proportion. If we turn it into a percentage, we'd call it a percentage. Okay. All probabilities or all phenomena have a sample space of the probabilities of all the possible outcomes. So the sample space of a phenomenon is the collection of all possible outcomes. Okay, so for example, if you were to roll a die 6 that has 6 sides, let's say that they are numbered 1, 2, 3, 4, 5, and 6. Okay, and let's say that we wanted to know, well, what are the, let's say each individual number. Well, there are 6 possible outcomes: 1, 2, 3, 4, 5, and 6. That would be the sample space of the event or of the phenomenon. We could also say, even and odd numbers, in which case the 2 possible outcomes are an even number or an odd number. So if we just said even and odd, then the sample space would be only 2 possible outcomes, an even number or an odd number. Whereas with the numbers, there's 6 possible outcomes. Okay. All probabilities add up to 1. Okay, so for example, the probability of rolling an even number is, so 2 is an even number, 4 is a number, and 6 is an even number. So three of these events are the outcome even number, and the total number of events is 6. So there's a 3 out of 6 chance, which is 0.5, that's 1/2, that we're going to get an even number. Okay, and then there's also there's a 1, a 3, and a 5. Those are the odd numbers. So there's a 3 in 6 chance, which is 0.5. That will get an odd number. And if we add up 0.5 plus 0.5, then we would have 1. Okay, and so the probability, all of the probabilities, they add up to 1. Now, if the probability of something happening is 0, this is an impossible event. Okay, so 0 probability means 0 possibility that it would even happen. If the probability of something happening is 1, it is a certain event. There's no chance that anything other than that one thing will occur. So for example, what is the probability of rolling the die and getting a number, any number? Well, the probability of getting any number would be 1, because we know when we roll the die, we're either going to get the number 1 or the number 2 or the number 3 or the number 4, etc. Okay. Probabilities that are larger than 0.5 occur more often. Probabilities less than 0.5, they occur less often. And the closer that a probability is to 0, it's far more unlikely, while probabilities that are closer to 1 are almost certain to occur. Okay, so the closer a probability is to 1, the more certain the event is. Now, a sample space is collectively exhaustive. Okay, a sample space has to be collectively exhaustive. Okay, it includes all possible outcomes. Collectively exhaustive means including all of the possible outcomes. Okay, so for example, when we say rolling a die, will we get an even number or an odd number? If we just put even in the sample space, this doesn't include the possibility of odd numbers. And so we have to include both even and odd. If we roll the die and we want to know what number we're going to get, the sample space includes all of the numbers, 1, 2, 3, 4, 5, and 6. But if we just said 1, 2, 3, 4, and 5, it's missing one of the possible outcomes. So in order to be a sample space, to be collectively exhaustive, it has to have all of the numbers included, okay? An event is called disjoint if two events are called disjoint if they can never occur at the same time, okay? Sometimes we call these events mutually exclusive. An example of disjoint events are if we were to ask a person, are you employed or are you unemployed? No person can be employed and unemployed at the same time. At any one time, a person is either employed or they are unemployed. And if they are employed, they're not unemployed. And if they're unemployed, then they are not employed. Therefore, employed and unemployed are what we call disjoint events, or we call them mutually exclusive events, okay? And then another, I think this is the last of our definitions. Two events are called independent if the probability of one of them happening is the same, even if the other event occurs or does not occur, okay? So if another event occurs and the probability, let's say the probability of something, of an event is 0.36, okay? Look, this is greater than 0, but it's less than 1, okay? And almost all probabilities are greater than 0 or less than 1, okay? So if the probability of an event is 0.36, whether a different event, so will be event 1, and there's another event. If that event occurs, the other event, then the probability of this event is 0.36. But if the other event does not occur, the probability of this event is still 0.36, then those two events are what we call independent. And I want to do an example of that right now. You can see right down here we have a couple of examples, and we're going to talk about those examples. Whoops, let's bring that back. Okay, there we go. All right, so look at this. Think about the probability of rolling a 5 on a 6-sided die, okay? So since there are 6 numbers, 1, 2, 3, 4, 5, 6, okay? And let's assume that each number is equally likely. Then the probability of rolling a 5, the probability of a 5 is 1 out of 6. That's the probability, okay? But what about the probability of rolling a 3? Okay, well, suppose the probability of rolling a 3 is also 1/6, okay? Let's say somebody rolls a die and they get a 3, okay? Then they roll the die a second time. Is the probability of getting a 5 still 1/6? Yes, it is. It's always 1/6, okay? So let's say they roll a die and they do not get a 3. They don't get a 3, okay? Well, is the probability of rolling a 5 still 1/6? Well, the answer is yes, it's still 1/6. Therefore, rolling a die, a 5, any number on a die 6 is an independent event, okay? And I'll give you another example of that. Suppose I roll a die and I roll a 3, okay? And then I roll it again and I get a 6. Then I roll it again and I get a 4. Then I roll it again and I get a 1. Then I roll it again and I get a 2. Now, the only thing I haven't rolled is a 5. I've rolled a 1, a 2, a 3, a 4, and a 6. So I haven't rolled a 5, okay? Is the probability, am I definitely going to roll a 5? If I roll the die again, is it definitely going to be a 5? No, it won't. What's the probability that it will be a 5? 1 out of 6. This next roll could be a 1 or a 2 or a 3 or a 4 or a 5 or a 6. And so just because I've already rolled a 3 and I've already rolled a 6 and a 4 and a 1 and a 2 does not guarantee that the next roll is going to be a 5. There is a 1 in 6 chance that it's going to be a 5. And that's because rolling a die is, the outcomes on rolling a die are independent. Okay? Now let's talk about dependence. So down here, dependent, the probability of drawing a king of hearts from a regular deck of cards, okay, after drawing another card, okay? So here's what I mean by after drawing another card, okay? Let's think about drawing the king of hearts if I didn't draw another card, okay? So let's think about this for a second. A deck of cards has 52 cards, okay? One of them is the king of hearts, okay? We're going to write K and then H for king of hearts, okay? If I do not draw a card, no other card was drawn, then what's the probability? What's the probability of drawing the king of hearts? Well, there's 52 cards and one of them is the king of hearts. So there's a 1 in 52 chance that I will draw the king of hearts. But what if I've already drawn a card? What if I did draw a card? So let's say I drew a card out of the deck and I set it aside. Well, now there are only 51 cards left in the deck because I already drew a card. So now the probability of drawing the king of hearts is 1 out of 51. And 1 out of 52 and 1 out of 51 are not the same probability. And therefore, these two events right here are dependent. They are dependent. Why? Because the probability of the same event has changed because I did something else, okay? That's what a dependent event is.